Hey y'all, we're happy to be here in Orlando at AHR with Hearst Family Boiler Business. My name is Roman Soto with CWF. To my right I have Austin Clark, owner of CWF. To my left I got Colton Clark. To my far right I got Graydon Grovey, our equipment sales. And we're happy to introduce for CWF 2025 our new HVAC division. We have Kelly Hawkins. 2024 was a good year with us for Hearst Boiler Equipment. We finished a project in one of our local hospitals. It was a complete Hearst boiler steam plant. Brand new facility right next to Raiders practice stadium.
We're working really hard with our manufacturing plants, hospitals, process facilities, and this year we've really started to make an effort into the mining industry.
We have dedicated ourselves in our company to establishing a new training curriculum for up-and-coming technicians, for our in-house technicians and mechanics, to be able to service our customers better.
We're trying to encourage younger guys to come into the boiler and HVAC field and have proper training and in the classroom and in the field with hands-on training. We bought a lot of equipment in 2024. We bought plate rollers, laser tables, press brakes, shears, expanded into a new building.
We've added some rental boilers to our fleet as well as boilers to stock to help with the longer lead times when the customers are in need. We look forward to growing that business in 2025.
Hi, I'm Rob Hampton with CWF, and I'm the training manager for the company. And what we have here today is a training wall that we created, and it takes beginning students from the classroom, and they're able to come out here and actually see a demonstration of a basic burner setup with the controls. And so they'll be able to come out here starting with the fuel, control panels, and all the equipment on there, and be able to see the sequence of operation that we talked about in the classroom. They'll be able to come out and physically watch everything happen. And then we have on the back of the wall, we have switches that we can trip that will disable some of the safety functions and cause the burner not to run. And at that point then the student would be able to go ahead and troubleshoot and try to track out what isn't actually functioning, and they can do that based on knowing what a sequence of events are and how far he got into that sequence, and then backing that up with an electrical meter, being able to maybe determine where his power has stopped going. So it gives them the basic fundamentals on troubleshooting out in the field. We start with our LP tanks that we're running. They're portable, that we can bring in our fuel to run the burner. Just like out in the field, we'll regulate that pressure down to what the burner needs to operate. We have a main control panel that allows us to turn the burner on, gives us indications of whether we're on main flame, whether we're at pilot, whether we're in an alarm. Very similar to what you'll basically find out in the field. We have a flame safeguard that supervises the startup of the burner and monitors the flame to make sure it's there when it's supposed to be and it's not there when it's not supposed to be. We come down, we have our typical safety equipment like low gas pressure switches. We have main fuel shutoff valves. We have a normally open vent, and we have a high gas pressure switch. And then we have simulated pressure controls for a steam boiler that would normally be there to turn the burner on and off, protect the boiler from overpressurization. Also has controls to be able to modulate the burner and run the actual air-fuel mixture that is done with the linkage. Basic setup. We've chose the linkage, just basically it's a dying breed, but it's still quite a bit of it out there, and the newer people coming into the field still need to know the basics on how to set those things up and make adjustments because they're not obsolete yet. People are still using them. Just in the field, just like on a typical burner cabinet, you'll have an on-off switch, and once we turn it on, if all our safeties are met, then the burner will start and it will go through its sequence to be able to start up. And right now what it's doing is it's purging. It's a requirement that has to be made on a boiler for any unburnt gases that are in that boiler to be purged out of that boiler before you try to light a flame. Once it gets to high fire, purge, it's going to be able to open the air damper for maximum amount of air to flow through that boiler. It will do that for a specific amount of time, It has to prove to the control that it actually made it there. And once it's done purging, it will return back to its starting position. It has safety switches to prove that it made it there. And once those are met, then the burner will proceed to go ahead and light a pilot. And if that pilot is there, then it will go ahead and release the main fuel for the pilot to light. So right now, we're going to light a pilot. It's looking to prove that the pilot flame is there. If it is, it's now releasing the main gas. And once the main gas is established, it will pull the pilot away and it will check to see if the main flame is still there. At this point, it will continue to heat until we have normal controls, typical to like a thermostat in a house, that will tell it I have enough steam pressure, we can go ahead and shut down.
Hi, it's Graydon Groby with Clark Welding and Fabricating. I'm here in Las Vegas, Nevada with a new boiler install. These are two Hurst Series 400, 350 horsepower boilers. They're running high pressure steam, 150 pound design. They have a Hurst package with oil-on burner, Siemens controls. We've integrated the entire plant together, so the communication is great. Got a lot of cool controls on this system. We're gonna go over it today. So first, let's start on the burner. This is an oil-on burner. They're headquartered in Finland, but they have a facility in Thomasville, Georgia, so they're locally available. A really high efficiency burner. This unit is dual fuel with an FGR coming in to get down to 20 ppm knots. That was the requirement on this job, and we were able to achieve that no problem. These oil-on units use a Siemens LMV52. This unit has a 6-inch touchscreen on it, so you have a little bit better visual when you're adjusting the controls. We've got a VFD here. It comes on this unit, and then you can't see it, but up in the stack outside of the building, we've got an O2 trim sensor plugged in, so we can really tune this burner efficiently. We'll walk around here, we'll see our natural gas train. Just to have a little bit more feedback, we've put a natural gas flow meter in line so that you can read how much fuel you're consuming. And then our number 2 oil enters into the burner here. That gives you a backup fuel option in case your natural gas goes down. When we put this package together, it was specified that we use flange connections, so you'll see quite a few flanges on this boiler. We use a Siemens differential pressure transmitter controlled through a Siemens RWF5. That is going to control your water level in the unit at all times. That pairs with a primary low water cutoff. This is a McDonnell Miller 157. See the armored gauge glass next to that. It's just a little bit more durable. Your secondary low water cutoff is a McDonnell Miller 150. In addition to that, we've got a high water level alarm here. It's a McDonnell Miller 150. This job was specified with float level controls for every circumstance, so that's what we did. All right, I want to show you guys how the water enters the boiler. So this unit has a Hurst Stackmaster economizer. And as the water enters into the system, it goes through the economizer. That heats the water up around 240 degrees before it enters into the unit. For more precise measurement, we have inlet sensors on the water side and the air side, so you know exactly how efficient your unit's going, and you know exactly how many BTUs you're getting into your feed water before it goes into the unit. We've got a modulating control. This is a Schubert-Sulzer modulating motor that's controlled by the Siemens DP transmitter that we had on the other side of the boiler. 3-valve bypass, again all flanged, and then it enters into the boiler here. So for code, we have 2 quick and 1 slow bottom blowdown valve. The connections are here, and they meet in the middle at a common drain that goes towards your blowdown separator on the other side of the room. Yeah, so one other control we want to touch on is the low fire hold. This is a Siemens sensor that's plugged into the belly of the boiler, and that way you can measure your temperature and make sure your boiler's staying warm. Also on this unit, we've got an access ladder and platform that was built at the factory. You see here where the brackets are already pre-assembled. So whenever you get the unit, you just bolt it on and it's ready to go. So for supplying feed water to these boilers, we've got a really interesting setup here. Got a 30,000 pound an hour spray type deaerator from Hearst Boiler. We've got a vertical 600 gallon stainless surge tank from Hearst Boiler as well. This unit has a Siemens control system that monitors both units. We've got 3 feed water pumps from the deaerator, 2 feed water pumps from the surge tank. You've got N+1 redundancy with the feed water pumps. You've got primary and backup on the surge side. They're piped commonly so that in the case of a failure on this DA, you can run the transfer pumps directly over to this DA, supply these feed water pumps, and they will use their force to get water into those boilers and run them in an emergency situation. So here we have the control system for the DA and surge. The monitoring here is only possible because we have sensors placed in the unit to measure temperature, pressure. We've got another differential pressure transmitter from Siemens that controls the modulating valve that moves water into this DA and keeps it at a set level. You also can see your feed water set pressure along with the current operating pressure to make sure that your pumps are providing what they are supposed to. Right now, they're really running nice and easy. Your Grundfos pumps are actually CREs, so they have integral VFDs built into the pumps. That's a bit unusual to pair that with the touchscreen system from Siemens, but it does work. It was specified by the customer and that's the way they wanted it, so we put it together and it works like a champ. So just like you had on the DA, we've got a Siemens differential pressure transmitter that's giving a measurement over to this modulating makeup valve, and that's keeping your water level consistent in that surge tank. We've also got sensors for transfer pump pressure, and that's controlling through the touchscreen over on the other end. That's controlling these integral VFD pumps from Grundfos. Those are the CRE series. They're sized appropriately to get that water from the surge tank over to the DA and have it ready to be supplied into the boiler. All right, to kind of tie all these systems together, we have a Siemens 10-inch master panel. This receives Modbus signals from both boilers, and it receives a Modbus signal from the DA surge panel that we looked at earlier. It all marries it together into one unit. Then from there, it converts that Modbus signal to BACnet, which is what this building required from our controls.